Okay, so here we are going to work on numbers 5 through 8. So let's take a look at number 5. So number 5 and 6 are the force problems. Our resultant force is 162 pounds. So remember, these are our forces. The resultant force is the diagonal, and that's 162 pounds. Remember, this creates a parallelogram, and the resultant is the diagonal of my parallelogram. So 162 pounds must be exerted to move a refrigerator. If the two applied forces act on the refrigerator at angles of 43.6 degrees and 38.7 degrees with the resultant. So it doesn't matter which one you put where. So I'm going to make the bottom one 43.6 degrees, and the top one I'm going to make 38.7 degrees. So if you put them in different spots, that's okay, you still get the same answer as me. Find the magnitude of each of the two applied forces to the nearest tenth of a pound. Alright, so I have to find this one here, and I have to find this here. Alright, so let's take a look at this triangle here. So my y, since it's parallelogram, is actually this piece over here. So I'm going to find my x and my y. So I need some more information. So I know this angle and this angle here are equal to each other because they're alternate interior angles. So this angle here is 38.7 degrees. I can get this bottom corner angle because all the angles of the triangle have to be 180. So I add these two together and subtract that from 180. And then that angle is 97.7 degrees. So what I'm going to use is I'm going to use law of sines here. So I'm going to start with x. I'm looking for the side, I have the angle opposite. I have side 62 and I have the angle opposite. So that is law of sines. So that's going to be 162 over sine 97.7 equals x over sine 38.7. Cross multiply, I get x sine 97.7 equals 162 sine 38.7. Divide by sine 97.7. And we would get 69, we actually get 112.73, which is 112.7. Okay, so now I'm going to get y. So I'm going to do the same thing. I have here, looking for a side, and I have the angle opposite. And again, I'm going to use side 162, and I have the angle opposite. So it's going to be law of sines again. So it's going to be y over sine of 43.6 equals 162 over sine of 97.7. So now I'm going to cross multiply, so I get y sine 97.7 equals 162 sine 43.6 divided by sine 97.7. So we get y equals, so just plug that in the calculator, and we get y equals 102.21, which is 102.2 to the nearest tenth. Okay, so let's take a look at number 6. Okay, so let's take a look at number 6. We have two forces act on an object. The first force has a magnitude of 78 and makes an angle of 31 degrees with the resultant. So we have 31 here. It's my parallelogram. The magnitude of the resultant is 124. Find the magnitude of the second applied force to the nearest pound, and then we have another piece to do also. So I'm looking for this, which is the same as that. So I'm going to be using this triangle here. All right, so let's see. I have here, I'm looking for a side. I have the angle opposite, and I have the other two sides. So that is law of cosines. So remember, law of cosines is a squared equals. So I'm going to use y squared equals, since I have angle 30 opposite it. 78 squared plus 124 squared minus 2 times 78 times 124 cosine of 31 degrees. So that you could just plug into your calculator all at one time. And we get 4,878.95 ... Let's do second square root second answer. And we get 69.849, which is about 70 pounds. All right, so the next part says to find the angle formed between the two, apply forces to the nearest degree. So I need this. So in order to get that, since that angle is between two different triangles, I need to get this angle here, or I need to get this angle. One of those two angles you have to get. So I'm going to get this angle here, because then I know these two angles here are equal, because they're alternate interior angles. And then I'll just add x and 31 together. So I'm going to use the fact that this is 70, and I have the angle opposite, and I'm going to use the fact that this is 78 and find the angle opposite, and that's law of sines. So law of sines would be 70 over sine 31 equals 78 over sine x. Cross multiply, 70 sine x equals 78 sine 31. Divide by 70. So we get sine x is equal to 0.57389959692. So we're going to do second sine, second answer. And this will give me the measure of angle x. So the measure of angle x is 35.02 degrees. And that means this angle here is 35 degrees. So then the whole angle would be 35 plus 31, which is 66 degrees. Okay, so let's take a look at number 7. All right, so I have a second degree trig equation. So I have tan squared theta minus 8 tan theta plus 12 equals 0. So I'm going to start off by writing a let statement. Let x equal tan theta. So I have x squared minus 8x plus 12 equals 0. So you can, this is actually factorable. If you didn't realize that, you could complete the square, use the quadratic formula. So this is x minus 6, x minus 2 equals 0. So we get x equals 6 and x equals 2. Make sure you replace your x back with tangent. So we have tan theta equals 6. Tan theta is equal to 2. So we have theta equals, so we do second tan of 6. Second tan of 6 is 81 degrees. All right, so 81 degrees is in quadrant 1. Let's figure out which quadrants we need to be in. So I look here, tan is positive, tangent is positive in 1 and 3. So 81 degrees is in quadrant 1, that's good. Now we need the angle that terminates in quadrant 3. Reference angle is 81, so it's 180 plus 81, which would be 261. So that would be the other angle. Okay, on to the other side, we do second tan 2. So second tan of 2 is 63 degrees. 63 degrees is in quadrant 1. Tan here is positive. Tan is positive again in 1 and 3. 63 degrees is in quadrant 1. Now I need the angle that terminates in quadrant 3. The reference angle is 63 degrees, so it's 180 plus 63, which is 243. So my other angle is 243 degrees. Okay, so let's take a look at 7b. Okay, so we have 3 sine squared theta minus 13 sine theta minus 10 equals 0. So we'll let x equal sine theta. So I have 3x squared minus 13x minus 10 equals 0. This is factorable. So when we factor this, we actually get 3x plus 2 times x minus 5 equals 0. So I make my t-chart. 3x plus 2 equals 0 minus 2 divided by 3. X is negative 2/3. So that's sine theta equals negative 2/3. Make sure you replace x with sine. X minus 5 equals 0. X is equal to 5. Sine theta is equal to 5. So hopefully you realize right away this one won't work because sine can't be greater than 1. That's outside the unit circle. If you do second sine 5, you won't get anything. You'll get an error. Okay, so let's work on the other one. So we do second sine. Second sine, negative 2/3 is negative 42 degrees. That's rounded to nearest degree. Okay, so let's see what quadrants we need to be in. Well, negative 42 is in quadrant 4. So I'm looking for sine to be negative. Sine is negative in quadrants 3 and 4. So I need this angle that terminates in quadrant 4. 360 minus 42. 360 minus 42 is 318. Make sure you cross that one off too. And now I need to be in quadrant 3. So I need this angle. Reference angle, again, is 42. So that's 180 plus 42. This will give me my blue angle. So 180 plus 42 is 222. Now this says in radians if you look at the interval, so I have to change everything to radians. So that's 318 pi over 180. Reduce the 318 and 1 over 180. Reduces to 53 pi over 30. And 222 pi over 180. We reduce 222 over 180 to 37, and that'll be pi over 30. Okay, so let's take a look at number 8. Okay, so number 8 is a complex fraction. So I'm going to split the numerator and the denominator. So I have 1 over a squared minus 1 over b squared divided by 1 over b plus 1 over a. Now in order to do same, change, flip, you have to have one fraction here, there's 2. You have to have one fraction here, there's 2. So in order to subtract fractions, you have to have the same denominator. So I'm going to multiply this denominator by b squared. And the numerator by b squared. And then I'll multiply the other one by a squared. So I get b squared over a squared minus a squared b squared minus a squared over a squared b squared. So subtract the numerators, keep the denominator. So that's b squared minus a squared over a squared b squared. All right, on to the other one. So I'm going to multiply the left fraction by a, the right fraction by b. So that's a over ab plus b over ab. Add the numerators, keep the denominator, a plus b over ab. Now we could do same, change, flip, and I also realize I can factor that. That's the difference of two perfect squares. So that's b plus a, b minus a, over a squared, b squared, times, flip the fraction, ab over a plus b. Now I can reduce b plus a and a plus b. They are the same exact thing. Addition is commutative. I can reduce one of these a's with one of these a's. So I'm left with a in the denominator. This b and this one of these b's reduce. So I'm left with b in the denominator. So in the numerator, I have b minus a. In the denominator, I have ab. So let's take a look at b. All right, so b is 4 over x minus 2 divided by 6 minus 12 over x. So again, same thing, I have to get one fraction. So this is 2 over 1. I'm going to multiply the numerator and denominator by x. So that's 4 over x minus 2x over x. Subtract the numerators, we get 4 minus 2x over x. Divided by, same thing here, I'm going to multiply the numerator and denominator by x. So I get 6x over x minus 12 over x. Subtract the numerators, keep the denominator, so that's 6x minus 12 over x. Now we can do same, change, flip. I'm going to factor at the same time. GCF is 2, so it's 2 times 2 minus x over x. Times, flip the fraction, we get x over GCF is 6 times x minus 2. Now we can reduce. 2 and 6 reduce to 1 and 3. 2 minus x and x minus 2 are not the same. They are opposites, and opposites, remember, reduce to negative 1. The negative 1 either goes in the numerator or the denominator, not both. X and x reduce to 1 and 1. So in the numerator, there is a negative 1, and in the denominator is 3. So my answer is negative 1/3. Okay, so I'm going to stop this here, and I'm going to start a new slide here. Okay, so just go back to the e-board to get questions number 9 and 10.